Today we're going to look at a 2018 Ford Explorer that the driver's side headlight won't turn off until the vehicle has been shut off for about 20 minutes. Probably the best place to start for this problem to make any sense is to take a quick look at a wiring diagram. So we're going to have the left headlight with our problem, a right headlight, and a body control module. The body control module is going to have power to it at all times, and it's going to have circuits going to the left headlight for the turn signal, the low beam, the high beam, the side marker, and the parking lights. Unlike a conventional headlamp setup, whenever the vehicle is on, the BCM supplies voltage to the adaptive front lighting module, or the headlight module. It's a control module that's attached to the bottom side of the headlamp assembly. It does unbolt from the bottom of the headlamp assembly, and it can be replaced separately. Its main feature is to control the low beam LED headlamp, and features such as daytime running lamps can be controlled through it as well. But whenever the key is on, it's going to supply power to that through the low beam circuit. The low beam circuit will stay powered for 15 to 20 minutes after the vehicle is shut off, and at that time the battery saver feature shuts it down. And the battery saver feature is just where the BCM shuts off power to things that shouldn't have power when the vehicle isn't running, just to ensure that if something gets left on, the battery on the vehicle doesn't get drained and it'll start the following day. Now there is going to be a couple more wires on this headlight. There's going to be a LIN wire from the BCM to the headlight, and that is a network communication wire. The LIN wire is going to be used by the BCM to communicate things to the headlights like turn on, turn off, run on daytime running lamps. It's also going to be used by the lighting control module to pass back issues it sees like a short or an open. We're also going to have 3 ground wires coming out of the headlight assembly. One is specifically for the high beam, low beam, one is specifically for the turn signal and parking lights, and then the third is the ground for the control module. And if the BCM does sense a short on any of these circuits, it will shut down power to that circuit. And even if you fix the problem, you will have to clear codes on the BCM before it will restore power to it. Now the passenger side headlight is going to be wired in basically the same way. The LIN networking wire going to the headlight is just going to have a splice in it and T and go over to the other headlight as well. And the same for the parking light circuit. Everything else will have individual circuits again. I'll go ahead and draw the internals on the headlights here so that makes a little more sense. So now that we've looked at how the headlights are wired and how they're supposed to operate a little bit, and knowing that there's 3 modules and a network line involved, I'm going to start diagnosis by retrieving the codes out of this vehicle. I'm going to be using 4Scan Lite on an iPhone here for diagnosis today. And it's connecting. I'm going to select 2018 model year. Okay, we're connected to the vehicle and we're going to look at the errors. So the body control module has a B14E5 in it for the left front enhanced lighting system. And reading the definition on this code, we can see it's a bus signal message failure. And what that means is the body control module can't communicate with the left headlight. Now something you need to know about this type of a system is that if there's no communication to the headlamp control module, it's going to default to turning the low beam on. And they do that because if you're driving at night and there's a headlamp failure, it's bad if you have no headlights at night. So if there's a failure in the system, it just defaults to the low beam being on. And that makes perfect sense with the problem we're seeing on this vehicle. Whenever the vehicle is turned on, all those circuits going to the headlight power up. And if the headlight can't communicate with the body control module to know if it's supposed to be on or off, it's going to default to turning on the low beam. And after you shut the vehicle off, not knowing if it's supposed to turn off or not, it's going to stay on until the battery saver feature shuts down the power to the headlights. Now I'm going to go ahead and scroll down the list just to see if anything else had any codes in it, and it looks like all the other modules are good, no codes. So if we think about our wiring schematic we were looking at earlier, the BCM's got to be able to communicate because it's communicating with the right headlight. And we know that because the passenger side is operating correctly and there are no codes for the passenger side headlight. It could be the module itself in the driver's side headlight. All those really module failures are fairly rare unless the headlight's full of water and moisture's getting inside the module. Or it could be a wiring problem, and if it was, it would have to be between the splice and the driver's side headlamp, because we know the passenger side works, so the circuit has to be good to that point. And probably the easiest way to check for a wiring problem is going to be to unhook the battery so there's no communication on that network line, and then just do an ohms check with the DVOM from the right headlight to the left headlight on that wire. So we've got our DVOM, we've got both headlights disconnected, the battery's disconnected, and I've got a pin inserted in each connector. The LIN wire is a yellow wire with a purple tracer, and we're plugged into it on both connectors. And as you can see, the circuit's reading open.
A few moments later.
So I went ahead and pulled the air filter to make it easier to get to the wiring harness for this, and I was trying to get to the splice. There's only a couple feet of wire between the left headlight and the splice for the LIN circuit. And while looking for the splice, I found a broken wire. And it was sealed inside the harness. I cut the harness open so I could get to it and visually inspect. Like I said, I was looking for the splice, but it's got green corrosion on it, so obviously there was some kind of perforation in the insulation on the wire and allowed moisture to get in there and corrode the copper until it turned green and broken too. So here we've got the wiring repaired. I've got a couple inch piece spliced in there, soldered in and heat shrank. The loom's all taped back up and ready to go. Let's try clearing the codes and see if they go away. So, and we've got an additional code now, but I don't think we're going to worry about that since we've had all the headlight stuff unplugged. Scroll down, and there it is. BCM, no codes in it. I think we're good. The headlights seem to work right, and we've got our problem fixed. If you found this helpful or interesting, please click the like button down below. We got a lot more great stuff coming up, so please subscribe. And as always, have a great week.